Jai Hind everyone. Myself Deepti Arora, Assistant Professor, MCA Department, Ajay Kumar Engineering College. Today's lecture is on networking software, subject computer network, subject code KCA 303. Before starting, I would like to tell that networking software studying is the basic concept behind studying the OSI layers and the TCP/IP layers. Networking hardware, we have studied about the network topologies and different areas of network, that is LAN, MAN and WAN. But while studying the network software, it is necessary to know about the designing issues before studying the OSI layers and the TCP/IP layer. The first computer network designed with the hardware as the main concern and the software was an afterthought. That is, when designing the computer network, the designers thought that hardware is the main concern, but actually not. The software is the main concern. This strategy no longer works. Thus, they have implemented the software first and then the hardware. So, the network software is now highly structured. Some software structuring techniques are protocol hierarchies, design issue for layers, connection-oriented and connection-less services, service primitives, and relation of services to protocols. These are all the designing techniques or the design issues that while designing the networking software, every network designer has faced. So, what are these issues? Let us discuss them in detail. First one is protocol hierarchy. To reduce the design complexity, the networks are organized as a stack of layers or levels. Stack of layers means, as discussed, one by one. Next, each layer offers a service to the upper layer. When it is stacked one by one, so the layer below the above layer is providing the services to the below layer or the above layer. Layer N on one machine carries on a conversation on the layer N on another machine. That is, if host A is having its layers and host B is having all the layers, then while connecting through layer 1 to layer 1 on host B, these layers are known as peers. Sorry. Protocol. It is an agreement between the communicating parties on how the communication is proceed. That is, what is to be done, what are the rules and regulations of communicating of data from one layer to another layer. Service, set of primitives, or we can say the operations that a layer performs to above the layer or the layer below it. Next one is interface, that is the service primitives operation that the layer is providing from the below layer to the above layer. Then that is the interface we are providing, what interface we are giving, what are the services we are giving, what interface we are using to provide the services to the layers. Network architecture, that is a set of layers and protocols, what we are talking about here. And last one is the protocol stack, that is the layer stack, and each layer is having a set of protocol. So we are having a protocol stack here. So this is the layer diagram. Here layer 1, host 1 is having 5 layers, layer 1, 2, 3, 4, 5, and this is the layered stack. And host 2 is similarly having the layer stack, layer 1, 2, 3, 4 and 5. Now, the layer 5 is providing the service to layer 4, layer 4 is providing the services to the layer 3 and similarly to the below layers. How it is providing the services? Through this layer interface. It is written layer 4 by 5 interface, that is layer 4 and layer 5 is using an interface to provide the services to each other. And at the last, there is a physical medium where the actual transmission takes place, and here are the protocols. This is a stack of protocol. Each layer is having protocols sharing with its peers, so layers are having protocol stack. Okay, let us understand this layered structure diagram through this example. This is a philosopher translator secretary architecture. We have seen there, this is layer 3, layer 2, layer 1, and similarly on the host A or host B, we can say this is 1, 2, 3 layers. We have studied in the previous year there are 5 layers, but in the example we are studying here only 3 layers, just for the conceptual understanding of the concept. So here at location B, the philosopher only knows 2 languages, that is the Dutch and the Chinese. And the location A, the philosopher only understands 2 languages, that is the Urdu and the English. Now, the philosopher at location B wants to communicate to the philosopher at location A or wants to send some message. Now, he wants to send the message through the layers. He is using the translator because he don't know the language of the philosopher at location A. So, he is using the translator who translates the message. That is, he is providing the services to the philosopher. Now, the translator translated the message into the known language and he passes on to the secretary. Now, the secretary uses a physical medium, that is the fax. The secretary uses physical medium. He uses the fax and faxes the machine over this physical medium. This physical medium is used to transfer the message at location A. Now, the receiver at location A, that is the translator again, the receiver again, uses again the fax as protocol is used, that the fixed medium will be used. So, the message is transferred over this line and received by the philosopher or translator at location A. Now, the secretary transformed that message to the location or translator, and then the translator translate this message to the philosopher, and the message he got is, I like rabbits. Example how this layered message is transformed. This is again an example how the message is transformed in this layered architecture. See, layer 1, 2, 3, 4 and 5 are here also, and this one is the actual message to be sent to the receiver. We can say this is the sender and this is the receiver who wants to receive the message. So, actual message is at layer 5, the protocol is used and message is transferred using the services to layer 4. At layer 4, a header is applied. Why the header is applied? So, to prevent the error control or the flow control at the receiver end. So, when the message is directly transferred at the receiver end, no error in the message got predicted. At the another level, when the message is sent to the next layer using the services provided by the layer 4, the message is too long. As a prediction that message is too long, so it is divided into 2 parts, message 1 and message 2. Again, the messages when divided, the first part is having the header, so it is included in the first part, header 4. And at the layer 3, to prevent the error, it is again applying the headers here, header 3 in both the messages. Next, when it is again sent to the layer 4, here it is in the form of packets. And here, when the message is again transferred, it is again distributed in the form of frames. So, again the header is applied, H2, in the second layer. The previous one is already having the header, so it is in the form of messages. But here, the trailer is also provided, header and trailer, because each frame is to be transferred in a series. So, to prevent the order of the series, a trailer is applied in each frame. And at the end, through the one layer, there is a physical medium, that is the source machine and the destination machine, where the actual bits are transferred. And again, this layer is again providing the services and message is received by the receiver. Okay, now the design issues for layers. We have designed these layers, that is the network designer have designed these layers, but what is the actual problem we are facing when we want to transfer the message over these layers? So, here is the design issue. The first one is addressing. What is the address we are using? The senders must be having an address or the receiver must be having the address. The address is the MAC address or the IP address to whom they want to send the actual message. That is the senders and the receivers address involved with a particular message. Okay, next one is error control. As we have seen here, headers are included to prevent the errors. The main design issue is the error control. How to send the correct message from the sender to the receiver. That is, the more powerful codes allow for error correction are to be applied between the layers so that actual message, what is the actual message without any error, is to be transferred. What error can be occurred? The error can be that the bits can be transferred, that is at the place of 0, 1 get transferred, or at the place of 1, 0 get transferred, or the packets we are having actually got damaged or corrupted. So this is the error main issue in the error control. Next one is flow control. By the name it is saying flow. That is the flow of packets, flow of data, flow of frames from sender to the receiver. The main problem here is that we are having the fast sender and the slow receiver. That is, how to keep that possible, that when we are having the fast sender, that is, sender is sending the data packets too fast, but the receiver is slow, that is not able to receive the packets or send the feedback. So what is to be done here is the actual problem design issue in the layer. That is, the sender is sending the messages one by one, but the receiver here is not able to receive the messages. What the problem we could find here is that the receiver is not able to accept the messages. So the problem here could be the traffic. There would be too much traffic at the receiver end, or it would be possible there would be a congestion. That means the blocking could be done here. Next one is multiplexing. Multiplexing means the network bandwidth dynamically to be shared, which means that if we are sending data from sender to receiver, there may be possibility that there could be one sender and one receiver. But what could be the problem if the one sender want to share the data to the multiple receivers? So here, a fixed fraction of bandwidth that is used is to be shared according to the demand of the receiver. If there are many receivers and the one sender, then according to the demand, the sharing is done, which is the concept of multiplexing. Next one is routing. Another design issue is finding a networking path for data to be transferred. For example, we are having a host A and host B. Between there are many routers or repeaters are here, and through it we want to send the data. Here we can see there are 4 routers, and here we are seeing there are 2 routers who can route the message from A to B. That means A want to send a message to B. A is the sender and B is the receiver. What is the actual path A would choose? The actual best path is, that is the minimum path, shortest path. But if there is having any problem, that is router is collapsed or router is damaged or dead, then what could be done? So it is having the possible way this. So in design issue of layer, that the sender is able to route the packets from the network. It could design the minimum, the shortest path through which the data could be transferred. For example, if the packets are transferred from network is down in Germany and we want to send the packets from London to Rome via Germany, then we have to search the alternative path, that is London to Rome via Paris. Similarly, in this manner. Next one is the quality of service. What could be the quality of service? It is the quality just as like quality of video. If you are viewing a live video or you are downloading some video, some between the watching the video, it gets blurred or it gets stopped in between. So what could be the problem could be solved? This is through the network, that is the real time delivery at the same time. Means if you are giving a network video or audio data, then the quality of service should be maintained while transferring the data from host A to host B. The last design issue is cryptographic issue, that is confidentiality, authentication and integrity. Confidentiality means the message privately should be shown. It could not be shown to somebody else. Another one is authentication, that who could be able to see that message or listen to that message. And last one is the integrity, that is the message could not change. That is, if you have seen the subtext changes to the message, that is debit my account to 10,000 to debit my account to $1,000, $10 or $1,000. The actual message is integrated, not integrated, it's got changed. So these are the design issue of the layers while the network designers have faced while designing the network software. Another service is connection oriented and connection less service. Connection oriented service means we are having the proper connection, dial-up connection, and then we are sending the data, that is pick up a phone, establish a connection, dial the number, uses the connection, and hang up means releases the connection. That is actual connection takes place. Connection less service, that we are not making the actual connection, we are just assuming that the connection has made and the message is sent from sender to the receiver. This example is a postal system. The letter carries the full destination address and it is being routed through the system independently, and at the last the message got arrived. But it could be possible that if you are sending multiple messages, the second one may arrive the first. This could be the problem in the connection less service, but in connection oriented service it could not be the problem. The basic difference between connection oriented service and connection less service is, it could be a telephone system while it could be a postal system where the destination is given but not the actual proof is with us. Here the order is preserved, that the message is sent from one by one. Here order is not preserved. Conduct a negotiation, here the sender can conduct, or sorry, receiver can conduct a negotiation with the sender. Next one is reliable service or unreliable service. Reliable service, that is never lose data, but here the loss of data is possible. Acknowledgement is sent at the time where the actual communication is taking place. Acknowledgement is sent, no overheads and delays. Next one, service primitives, that is what the actual service is the layer above the layer is providing to the below it. First one is listen, block waiting for an incoming connection. Next one is connect, establish a connect with the waiting of a peer. Third one is accept, accept an incoming connection from a peer. Receive, send and disconnect. Let us study it in detail how the services are done. This is an example of connection establishment between two parties. First one is connect.request. Here the connection request is being established. Then connect.indication. A signal is sent to the party that the host A wants to connect to the host B. Connect.response. Now used by the callee, that is the receiver. Use this to accept or reject the call. Connect.confirm. Tell the caller whether the call was accepted or not. Now if the call is accepted, then the data.request, data request is being sent. Next, data.indication. Now the signal is given that the data is arriving at the receiver end. Disconnect.request. Now data has arrived, now the connection needs to be released. So a request is made at the sender that it needs to release the connection. Next, disconnect.indication. Now the signal is sent about the peer that the request is completed. Here are the service primitives. A relationship is shown. All the services, these are the services and these are the services which are the primitives here, are provided here. Here layer K wants the services from layer K plus 1 and providing the services to layer K minus 1. That is, the layer above provide the services to the layer below it. And each one is having a protocol here who is using these services. That is peer-to-peer layers, that is layer K at host B and layer K at host A is using a protocol to transfer the data from host A to host B, that is rules and regulations, and the services is being used by layers at the same level, same host. How it could be defined? A service is a set of primitives, that is the operations that layer provided to the layer above it or layer below it. The service defines what operations the layer is performed to perform on the behalf of its user, but it says nothing at all about what these operations is implemented or how these operations are implemented. That is, it is hidden how the services is being provided from layer to layer, but what services, what operations are to be provided, they are to be implemented or tell to the each layer or the user at each layer. The service relates to an interface between two layers, with the lower layer being the service provider and upper layer being the service user. That is, the services are related to an interface, as we have seen in the previous slides, that each layer is having an interface and through this interface the service is being provided. A protocol, in contrast, is a set of rules governing the format and meaning of the packets. That is, at network layer, at layer 3, we are providing the packets from layer N to layer N. So, protocol is a set of rules that govern how these packets are transferred. It could be 1,000 of bits packet, it could be a lakh of bit packets, or it might be a 10 bits of packets. Depending upon the how long is the message, the packet are to be made and the rules are to be made in which form these packets are to be transferred. Entities use protocols to implement these service definitions. That is, the set of rules and services what are to be applied each host, host A or host B, entities use protocols to implement these services. They are free or to change their protocols at wills. That is, if a protocol is set by a host A layers, then they are able to change those protocols. It is not mandatory that they are stick to what the protocols at first they have decided. They can change according to their condition. In this way, the service and protocols are completely decoupled. That is, it is not to be confused what are services and what are the protocols. If it is clear what are the services and protocols, then it would be better to understand the OSI layers and the TCP/IP layers perfectly. So, this is all about the network software, and rest we will continue with OSI layers and TCP/IP layers. Thank you.